Federation News Network.
Eine Aufnahme. Spanien.
Sitzung des IG.
Welcome to the Memory Library Subspace Network.
Space is big. I mean really big. Which means that the vast invisible web which weaves its tendrils through it is also very, very big. What exactly is it, and what is it made of? Well, that's a little complicated. The familiar material of the universe, like, your stuff, is known as baryonic matter, which is composed of protons, neutrons, and electrons. But despite organizing the matter we see in space, this dark web is barely visible. That's because it's made up of cosmic filaments. Filaments are massive thread-like formations comprising huge amounts of matter, including galaxies, gases, and dark matter, which exerts a gravitational pull but emits little to no light. They can be 500 million light-years long, but just 20 million light-years wide. At their largest scale, the filaments divide the universe into a vast gravitationally linked lattice interspersed with enormous dark matter voids. To hold the elements of the universe together, dark matter makes up approximately 80% of the universe. The missing matter could simply be more challenging to detect, made up of regular baryonic matter. But dark matter is mostly composed of non-baryonic matter. The lead candidates for such a composition are weakly interacting massive particles, which have 10 to 100 times the mass of a proton, but their weak interactions with normal matter make them difficult to detect. Neutralinos, massive particles heavier and slower than neutrinos, are also possible. The least popular type of neutrino, sterile neutrinos, are another candidate. And to finish your bingo card, the other types of neutrinos are electron, muon, and tau. Most of the rest of dark matter is a neutral axion, and uncharged photinos, which is my favorite pizza place. There are still, of course, large amounts of dark matter and energy unaccounted for, but the vast majority of matter in our universe is dark, in that it does not interact with light or any of the normal baryonic matter. As a result, much of the cosmic web is nigh invisible to traditional observation. In addition to the dark matter network, there also exists a similar web of magnetic fields. Cosmic magnetism is primordial, tracing all the way back to the birth of the universe. Because of this, weak magnetism exists everywhere, even in the voids of the cosmic web, the very darkest, emptiest regions of the universe. Omnipresent magnetism seeded the stronger fields that blossomed into galaxies and clusters. But the majesty lies in the delicate lines of cosmic filaments themselves. Stretching for millions of megaparsecs, these sinewy tendrils of galaxies act like great cosmic thoroughfares, crossing the black voids and connecting bright baryonic clusters. But this network is just a fraction of what really connects everything together. Essentially window dressing on the widespread mycelial network. See, what we consider our universe is in fact an enormous ecosystem, not just empty space. Life isn't restricted to planetary habitats or even this quantum reality. There's a seemingly infinite network containing the roots of a fungus, a vast microscopic web spanning the entire multiverse that includes the known universe and all quantum realities.
Prototaxites stellaviatori, a species made up of exotic material found not only in normal space, but in a discrete subspace domain known as the mycelial network. Its fungal roots, aka mycelium, spread across the universe, fanning out into infinity to create a matrix that serves as our intergalactic freeway system.
On Earth, about 90% of land plants are in mutually beneficial relationships with fungi. The 19th century German biologist Albert Bernhard Frank coined the word mycorrhiza to describe these partnerships, in which the fungus colonizes the roots of a plant. In mycorrhizal associations, plants provide fungi with food in the form of carbohydrates, In exchange, the fungi can help plants suck up water and provide nutrients like phosphorus and nitrogen via their mycelia. These functions are not only beneficial for life in the universe, it's altruistic. A complex and resourceful structure for sharing information, mycelium can adapt and evolve through the ever-changing forces of nature. These sensitive mycelial membranes act as a collective fungal consciousness. Earth's biosphere, from its atmospheric and geochemical macro processes down to the level of the least sophisticated forms of organic life, represents an emergent and self-regulating form of natural intelligence, a sort of sentience which seeks a state of equilibrium favorable to organic life. The universe's network is no different. The matter inside the network is different from that in normal space, but it nonetheless proved a complex, thriving ecosystem like that of its fungal counterparts on Class M planets. The mycelia strengthened and supported life throughout it and other realms. The Josep, for instance. There are species residing within the mycelial plane that specialize in breaking down all matter that enters the network and making it useful in new ways. In the mid-23rd century, Starfleet not only discovered this network, but also a species of spaceborne mega-tardigrade that had evolved the uncanny ability to enter the network and instinctually navigate its pathways. It used them as shortcuts through subspace to all manner of realities. Those traveling along the network might find themselves near-instantaneously transported over long distances or to the same coordinates in a different universe. This ability would prove a game-changer for stellar travel, being able to jump vast distances nearly instantly, hence the spore drive. The displacement-activated spore hub drive, or spore drive, was the brainchild of two stellar mycologists and engineers, Paul Stamets and Strahl, who'd been working on the concept since 2244. Their research was based on the insight that such spores were not only the progenitors of panspermia, helping seed the universe with life, but also the building blocks of energy across the universe. Initially confined to a lab following the outbreak of war with the Klingons, Starfleet co-opted the research for military applications, much to the displeasure of Stamets. Two science vessels were tasked to develop and test a workable engine to access the network and tip the balance of power in the Alpha and Beta quadrants. The two scientists were split up and given teams on different vessels, the USS Discovery and the USS Glenn, so they could work twice as fast. They took different approaches, running parallel research into the drive's functionality. The Discovery, under the guidance of Stamets, maintained a large spore cultivation bay. They grew and used their own spore colonies to fuel the drive. The act of jumping into the network was probabilistic, meaning that the longer the jump, the more possible destination outcomes there were. Both ships lacked the processing power to make the requisite number of calculations, and so long jumps resulted in navigational instability. In other words, they weren't very good at it. They could only achieve jumps that measured in hundreds of kilometers, which is not very impressive. Ultimately, Starfleet abandoned research into spore drive technology. Considering its promise, this seems rather boneheaded, but they had very specific concerns and gaping holes in information. Spore drive tech became interstellar roadkill for several reasons. Firstly, it was dangerous. The research and development was rushed along due to the desperate conditions of the First Klingon Federation War, so much so that the USS Glenn was lost while testing the drive's real-world application. In contrast to Discovery, the Glenn team, led by Strahl, used dry spores for their spore drive. This led to a mega-tardigrade infiltrating the ship's cargo stores. Finding that the innocent creature could communicate with the spores, the crew built an invasive mechanism in their reaction cube that would connect it physically to the drive system, performing a role akin to a navigational computer. That's strike one. You see, this allowed them full navigational control over the probabilistic nature of the spore drive, enabling them to make jumps of 90 light-years to the Beta Quadrant in under 2 seconds, but caused the tardigrade intense distress. The crew added additional shielding to the engineering lab to contain it, but ignored its obvious pain. And unlike the use of Medusans as physical navigators, the tardigrade was nothing more than a beast of burden held against its will. See, Medusan navigators were rare aboard Federation ships as they rarely left their own system. But when they did serve in Starfleet, it was by choice. A Medusan was capable of traveling on board a Federation ship, though this required them to be within highly specialized electromagnetic containers. There was a great deal of danger in such cases since their non-corporeal physical appearance was so baffling to humanoid brains that it caused severe cognitive damage. That has more to do with the typical humanoid brain and the way that it rationalizes visual input than a Medusan being ugly, but it's much more fun to say that way. Special viewers were required by individuals who sought to see a Medusan outside their protective containers as they filtered out dangerous electromagnetic frequencies, thus lessening the potential damage. Similar accommodations were arranged for the tardigrade in the form of the reaction cube, but for a much less ethical intent. Tragedy struck when the Glenn hit an undetectable Hawking radiation firewall while exiting the mycelial plane. The resulting impact caused the drive system to spin out, exerting extreme helical torsion that killed the ship's complement and left evidence on the hull of a basiodesic rupture. Since you don't know, that's a spore-producing reproductive structure found in a group of fungi that includes mushrooms, shelf fungi, rusts, and smuts. That's not a judgment, that's actually what they're called. Since you weren't going to ask, the poor tardigrade was unaffected by the disaster and broke out of the reaction cube to run amok about the ship. Good for him. A group of Klingons then boarded the Glenn, only to be killed by the big lug, who'd become highly aggressive. Well, I'd be pissed too. In addition to this relatively obvious red flag, travel along the network proved damaging to its very structure. It exposed the ecosystem to contamination by regular matter and invasive species, plus it posed numerous dangers to native species within. Strike two. And the ultimate reason to dropkick this technology was more existential. Well, and practical. The network's ecosystem is the backbone of all life in the known universe, and most of its energy. And it extended to every quantum reality. If a nefarious party wished to weaponize it, like Starfleet did, it could mean genocide on a scale never before seen in all of existence. For example, and keep this under your hat, but the Mirror Universe iteration of Stamets developed a powerful engine fueled by spores from the network. Doing so, however, eroded the balance of the ecosystem and prevented the fungus from regenerating. This is what we, as historians, refer to as a bad idea. Had the engine not been destroyed, it could have eliminated all life in the universe, ruining everyone's weekend plans. And since I'm assuming that none of you know the rules of baseball, the fourth strike has to do with the last one. The network allowed for an intentional, if challenging, path to the Mirror Universe. Both universes' biggest powers have agreed that travel between the two is extremely dangerous, and due to its nature, could very easily violate the Prime Directive. On our side. For all these reasons, Starfleet decided to scrap the pursuit of the technology and keep hidden any knowledge of their breakthroughs. As far as anyone outside the highest clearance levels knows, the Mycelial Network is just another scientific wonder. So let's keep it that way, huh?
Star Trek and all related marks, logos, and characters are solely owned by CBS Studios Inc. This fan production is not endorsed by, sponsored by, nor affiliated with CBS, Paramount Pictures, or any other Star Trek franchise, and is a non-commercial fan-made film intended for recreational use. No commercial exhibition or distribution is permitted. No alleged independent rights will be asserted against CBS or Paramount Pictures. Live long and prosper.